No intro. Jupiter doesn't deserve one. Number 10. The cannibal planet. When Juno mapped Jupiter's gravity field, the data revealed something the team did not expect. Close to 40 Earth masses of heavy elements sit packed inside the core. That is more rock and metal than exists in all the terrestrial planets combined. It did not drift there gently. Billions of years ago, the young Jupiter swept through the early solar system and swallowed entire planetesimals, dozens of baby worlds, gone. Their remains are still down there, pressed into a dense, fuzzy core that reaches halfway to the cloud tops. The planet grew fat by eating its neighbors, and the evidence of every meal is still buried inside it. But Jupiter kept more than the leftovers. It also kept the weapon it used to hunt. Gravity. And that gravity does something else that is far worse. Number 9. Extreme radiation belts. Jupiter's magnetic field traps high-energy particles in donut-shaped belts that wrap around the planet. On Earth, our radiation belts deliver a gentle drizzle. Around Jupiter, the dose rate in the worst zones reaches around 20 million rads over a mission lifetime. NASA compares that to more than 100 million dental X-rays fired at a single target. To survive this, Juno carries a titanium vault with walls 1 centimeter thick, weighing 200 kilograms. It cuts the radiation hitting the electronics inside by a factor of 800. Even with that protection, the spacecraft zips through on fast polar orbits and spends as little time as possible near the equator. Mission planners call them science orbits. Most engineers would call them escape routes. Where do those particles come from? Volcanoes. A tiny moon called Io feeds the belts with about a ton of sulfur and oxygen every second, but that story comes later. First, you need to understand what happens when you actually try to visit. Number 8. The graveyard of probes. On December 7, 1995, the Galileo atmospheric entry probe hit Jupiter's upper atmosphere at 47.8 kilometers per second. That is the fastest any human-made object has ever entered an atmosphere. The 339-kilogram capsule endured 228 times the force of gravity during deceleration. Its carbon phenolic heat shield reached close to 15,000 degrees on the surface. After the shield separated, a parachute deployed and the probe drifted down. For 57 minutes, it sent back data on wind speed and chemical composition. Then at a depth of about 160 kilometers, the signal stopped. Pressure had reached 23 times Earth sea level. Temperature had climbed past 150 degrees. No wreckage was ever found. Nothing floated back up. The probe simply ceased to exist somewhere in the haze. That was the only direct sample of Jupiter's atmosphere humanity has ever collected. Number 7. Violent cannibalistic storms. The Great Red Spot has been raging for at least 350 years. In 2021, Juno's microwave radiometer revealed that it extends roughly 500 kilometers below the cloud tops. To put that in perspective, the Mariana Trench is only 11 kilometers deep. This storm goes 45 times further down than anything on Earth. Winds at the outer edge hit around 680 kilometers per hour, but what makes the spot truly strange is how it stays alive. It feeds on its neighbors. Smaller storms that form nearby drift toward the spot and get caught in the rotation. Each one gets absorbed. Each one adds energy. The Great Red Spot is a hurricane that eats other hurricanes to keep itself running. Lightning here carries its own surprises. Some bolts burn 100 times brighter than anything recorded on Earth. And Juno found a type that should not exist at all. More on that in a moment. Number 6. The crushing descent. There is no surface. If you drop below the clouds, you would fall through an atmosphere that smells like rotten eggs and ammonia, a thick soup of hydrogen and helium with traces of methane and hydrogen sulfide. At first, the wind would be manageable, A few hundred kilometers down, it would hit supersonic speeds and stay there. As the pressure climbed past 100 atmospheres, the gas around you would thicken into something closer to warm syrup. Your vessel would not be crushed in an instant. It would be squeezed slowly as the density rose and the temperature climbed past 500 degrees, then 1,000, then several thousand. No parachute survives this. No hull resists it. The Galileo probe lasted under an hour. Anything else would do worse. There is no crash at the bottom because there is no bottom. Just an endless gradient of rising heat and pressure fading into something no instrument has ever recorded. Number 5. The boiling metallic ocean. About 7,000 kilometers below the cloud tops, the pressure passes 2 million atmospheres. At that depth, something strange happens to hydrogen. The molecules break apart. Electrons shake loose and begin flowing freely. The gas becomes a liquid metal. Scientists call it liquid metallic hydrogen. Nobody has ever produced it in a laboratory because no press on Earth can hold 2 million atmospheres long enough to study it. What we know comes from calculations and from what Juno's magnetometer picked up. This layer conducts electricity the way copper does. It churns with convection currents driven by temperatures near 10,000 degrees. For context, lava on Earth sits at around 1,200 degrees. This is 8 times hotter. That churning ocean of liquid metal is the engine behind Jupiter's magnetic field. No, it works like a planetary dynamo spinning conducting fluid into a magnetic bubble that extends 700 million kilometers into space. Anything that tried to sink this deep would have been liquefied long before arriving. Number 4. The screaming magnetosphere. Space is mostly silent, but Jupiter screams. When Juno's Waves instrument recorded the moment the spacecraft crossed Jupiter's bow, shock, the audio sounded like a freight train dragging sheet metal across gravel. The bow shock sits roughly 100 Jupiter radii from the planet. That is over 7 million kilometers out. The violence starts that far away. Deeper inside the magnetosphere, charged particles spiraling through the magnetic field lines produce what physicists call synchrotron radiation. When NASA converted those emissions into audible frequencies, the result was a low grinding howl punctuated by sharp rising shrieks. If you played the recordings for someone without context, they would guess it was a machine tearing itself apart. Jupiter also broadcasts from its auroras. The polar regions emit radio bursts in a frequency band between 10 kHz and 40 MHz. Those signals have been reaching Earth since before we knew what they were. In the 1950s, radio astronomers picked up the noise and could not identify the source. Jupiter had been screaming at us for years before anyone thought to listen. Number 3. Ammonia hail. In 2020, a team led by Tristan Guillot proposed something no one had predicted. High in Jupiter's storm clouds, water ice crystals get lofted by powerful updrafts. When they reach altitudes cold enough to freeze almost anything, ammonia vapor drifts in and acts as antifreeze. It melts the ice into a slushy ammonia water mixture that collects more layers of ice as it bobs up and down in the storm. The result is a frozen sphere about the size of a softball. Scientists name them mushballs. When the mushballs grow heavy enough, they plummet. As they fall through the clouds, friction and static charge build until the surrounding gas discharges in bright, shallow flashes. This is the strange lightning Juno found. It happens far too high and far too cold for liquid water alone to explain it. The mushballs solve the mystery. These ammonia hailstones also explain why Juno detected far less ammonia than expected in Jupiter's upper atmosphere. The mushballs kidnap it. They drag it down 150 kilometers or more into the deep atmosphere where it evaporates back into gas. The chemistry of the entire upper atmosphere is being rearranged by falling slush. Number 2. The cosmic slingshot. In July 1994, the world watched a comet called Shoemaker-Levy 9 slam into Jupiter. The comet had already been torn into 21 fragments by the planet's gravity on a previous pass. Fragment G alone struck with the energy of roughly 6 million megatons of TNT. That is 600 times the combined yield of every nuclear weapon on Earth. The impact scar from Fragment G covered over 12,000 kilometers, close to the diameter of Earth itself. A dark bruise in the southern hemisphere that stayed visible for months. Jupiter's gravity does this routinely. It captures passing comets and asteroids and either absorbs them or flings them onto new paths. Sometimes those new paths aim inward. Objects that would have sailed harmlessly through the outer solar system can be nudged toward Mars or Earth instead. The same gravity that shields the inner planets from some impacts also manufactures new threats. Whether Jupiter is a net protector or a net danger is still debated. The honest answer is both. Number 1. Io the Poison Factory. Remember those radiation belts from earlier? Here's where the ammunition comes from. Io is the most volcanic body in the solar system. Over 400 active volcanic sites dot a moon about the size of our own. The largest volcanic depression is called Loki Patera. It runs 200 kilometers across and contains a lava lake that periodically overturns its own crust. During major eruptions, plumes of sulfur and sulfur dioxide blast 500 kilometers above the surface. On a world with no atmosphere to slow them, they arc into space in perfect parabolic fountains. About 1 ton of sulfur and oxygen leaves Io every second. That material gets ionized by Jupiter's magnetic field and forms a glowing ring of plasma called the Io plasma torus. The torus sends charged particles into the radiation belts, creating the environment that cooks spacecraft electronics and forces missions to carry titanium armor. Io is trapped. Jupiter's gravity flexes its interior through tidal heating, keeping the rock molten. The moon cannot cool down. It cannot stop erupting. And it cannot stop feeding the radiation belts that make the entire Jupiter system one of the most dangerous places any machine or human could ever attempt to visit.